So if we had a normal class today, we would have had a warm-up where we went over a lot of these words. They might look really familiar to you, and how many sides they have and just some things about them. But because it's not a normal class, we're going to go over them in this video. So we're going to be flipping back and forth between this organizer and between the note slides that you should have with you. So the first thing we're going to talk about is how many sides each of these shapes have. Again, they should look pretty familiar, but you probably don't remember how many sides they all have. And they're actually in order. You'll see I have them written over here, but I'm going to go ahead and write them in these boxes, which is where you should write them. A triangle has 3 sides, quadrilateral has 4, pentagon has 5, hexagon has 6, heptagon has 7, octagon has 8, nonagon has 9, decagon has 10, hendecagon has 11, and dodecagon has 12. So these are vocab words that you're going to have to memorize if you don't know them already, so that if I ask you a question about a nonagon, you're going to have to know it has 9 sides to be able to solve it correctly. The other one you'll see up here is an n-gon, and what this means is it's kind of the general form, because there are definitely shapes with more than 12 sides, but I don't care if you know the specific names of those shapes. So for example, if it has 15 sides, you don't have to know what that's called. You would just call it a 15-gon. So if you ever see something like that, all it's doing is telling you how many sides it has without a specific name. So if you flip over to your notes, we're going to start where it says Theorem 8.1, Polygon Interior Angles Theorem. It says the sum of the measures of the interior angles of a convex n-gon is. So that sounds really crazy. We're talking about polygons, which are just closed figures with straight sides. And we're going to talk first about how many interior degrees they have. So you already know triangles have 180 interior degrees. Maybe you know a few others, but we're going to come up with a formula that tells us how many degrees the inside of these shapes have. Now, convex is highlighted here because a convex shape is kind of like your everyday normal shapes are convex. The way you can tell it's convex is that if I would continue all these sides, if I would draw a line through them, I never go through the actual shape. Not convex, you can see if I would continue like through this side, it goes through the shape. It goes through the shape. So this formula that we learned, it does not work for polygons that are not convex. I'm not going to trick you. I'm not going to give you one and then say, you couldn't do it. You get points off for that. I'm only giving you these. It's just something for you to know. The other thing is it has to be a polygon. So if it's something like this that has a curved edge, that's not a polygon, so it would not work for that. So the formula we're looking for here is the way to find the sum of the measures of the interior angles is we take n minus 2 times 180. Now what that means is n is the number of sides. So we already know about a triangle, so let's verify with that. If it was a triangle, n would be 3. If I take 3 minus 2, that's 1, times 180 equals 180. So that verifies for me that a triangle is going to have 180 degrees on the inside. Now if we look over here, I kind of just talked through this without looking at this. But now let's try it with a square or a quadrilateral. Maybe you have an idea how many degrees are in a quadrilateral. Think about a rectangle. It has 4 90-degree angles, so that should be 360. So let's try it. If n is 4, we would take 4 minus 2 times 180, and that would give us 360 degrees, which we know is correct. So what we're going to do is we're going to go back over to our graphic organizer and fill in a little bit here. So if number of sides we now know is n, the sum of the interior angles is n minus 2 times 180. So we're going to go through and fill in the rest of this column. A triangle we know is 180. A quadrilateral we found to be 360. So go ahead and use your calculator to find the rest of these interior degrees. If you want to pause the video and do that, go ahead, and you can check it when you start the video up again.